So systems of equations, linear equations with two variables, you should be good with. You've learned it in middle school, Algebra 1, believe in geometry, y'all did a little, and Algebra 2. So hopefully we can get through this with minimal examples, but always ask questions when you have them. Um, all right, so first of all, they're going to ask you in Math Excel, like if a point is a solution. So remember the easiest way to check that is plug it in. Remember they're giving you an X and a Y value and they give you an ordered pair. In order for it to be the solution, it has to work in both of the equations. All right, so here we get 2 minus 6 is equal to negative 4. Yes, it is. So then check and see if it works in the other equation. So does 2 plus 2 equal 4? And yes, it does. So this is, yes, it's a solution. All right, so then for number 2, same concept. We're going to plug in the 7 for x, the 6 for y. See if that works out to be negative 4. So it's 14 minus 18, negative 4. Yes, it is. All right, so checking the other one, 2 times 7 plus 6 is equal to 4. So is 14 plus 6 equal to 4? No, it's not. So this is no. All right, so system of equations is when you've got two equations working together, and the solution is the ordered pair that makes both of them true. So you just have to check the ordered pair in both equations. If it's true for both, then yes, it's an answer. If it's not true for one, no, it is not. All right, so solve by graphing. All right, so if I take this first one, in order to graph, we like to have it in slope-intercept forms, what most people prefer. So we're going to subtract x from both sides and then divide everything by 2. So y is equal to negative 1/2 x plus 3. So we will start at 3 on the y because that's the y-intercept and then go down 1, right 2 to get some more points. I'm going to do lots of points, especially if you're trying to freehand a graph. But if you're using a straight edge or graphing in Math Excel or cheating like I am with a drawing tool, just 2 points would have been sufficient. All right, for the next one, again, we want y by itself, so we're going to subtract 2x to the other side. Remember, you need to write down that you're subtracting 2x. I'm being lazy, I apologize. Divide by negative 1, and we get positive 2x plus 8. So, starting at 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis, and then we want to go up to over 1, but that takes me off of my graph even more. So we're going to go down 2 and back 1 because 2 negatives make a positive. We're looking for where they intersect. So as soon as you find that, you really should be good. Use a straight edge or do the best you can to get a really straight line. And then your solution is the ordered pair where they intersect. So this guy right here. So our solution is the point negative 2, 4. All right, so for this next one, if I try to get y by itself, you can subtract 3x, divide by negative 1, but I can also add the y, subtract the 2. So it'll be 3x minus 2 is equal to y. So we start at negative 2, we rise 3, run 1. Again, I'm using I'm setting a bad example because I didn't show all of my work, but just make sure on a test that you're showing all of your work so that you don't lose any points. All right, and then for the other one, we're going to add 6x, divide everything by 2. And you should notice that it's the exact same thing as the other one. If I go to graph it, we're going to end up with the exact same line. So those two lines intersect everywhere. So this one has infinite solutions. All right, so algebraic ways of solving. We have substitution and elimination. That's what you've learned in the past. So substitution is where you solve one equation for one of the variables, substitute it into the other equation. You'll figure out X or Y at that point, and then you can take that and plug it back into one of the originals, and you get your ordered pair. Now, substitution will always work, but it's easier when isolating a variable can be done without creating fractions. So you want to only do this when you have a variable that doesn't have a coefficient. Otherwise, you're making things harder than they need to be. Elimination is going to work better. On the test, I think they tell you which method to use, but they're not mean. They don't make you do elimination when it's going to make some fractions. All right, so for this one, if you're looking at what we have, the easiest thing to get by itself is this y. So if I subtract 2x from both sides here, then I get y is equal to negative 2x plus 1. So then I can take what y is equal to here and plug it in to this top equation. And it'll now say 3x plus 2 times negative 2x plus 1 is equal to 4. So 3x minus 4x plus 2, if I distribute here, is equal to 4. So then combining these, negative x plus 2 is equal to 4. Subtract the 2. Negative x is equal to 2. Divide by negative 1, and x is negative 2. All right, so now that I know x is negative 2, I can take that fact and plug it in up here. Does not matter where you put it. This is generally the easier place. Does not matter though, as long as you put it in for x in one of the equations that you have. So now we end up with y is negative 3. So our solution is the ordered pair negative 2, negative 3. Remember, ordered pairs are x and then y. All right, so that was your example of substitution. Elimination, which this book calls addition. So if they say the addition method, they mean the elimination method. And if you put those names together, you kind of get what's going to happen. You're going to add the equations together to eliminate a variable. Sometimes that works really nice. Sometimes you have to multiply one of the equations or both of the equations by something to get either the x or the y to cancel. Just remember that you either want x to cancel or y to cancel when you add them together. That's what we're going for when we decide to multiply. And then once you've added them together and eliminated a variable, you'll know the other one and then can go back and plug that in. All right, so if you look at this problem, I can't add the x's and get 0, and I cannot add the y's and get 0. But I can multiply by negative 2 down here and create a negative 4 that will then cancel out. So I'm not messing with the top equation. On the bottom equation, I'm multiplying all of the pieces by negative 2. And then when I add, the x's cancel because 4 minus 4 is 0. Add here and I get 11. Add here and I get negative 11. Divide by 11 to get y by itself. Y is negative 1. Now I can take that and plug it into any of the equations that I have. I generally go to this one just because I can draw that arrow easier. Literally my only reason for picking that one. None of them are better than the others. All right, so then this becomes plus 3. We will subtract 3 and get 2x is equal to 4. Divide by 2 and get that x is 2. So my solution is the ordered pair 2, negative 1. All right, so number 7. The first thing I want to do is make sure that everything has matching pieces lined up, and we like it to be standard form. So I'm going to subtract 3y and make this 2x minus 3y is equal to 9. I'm going to add the 3x, and this one will be 3x plus 4y is equal to 8. So then this is the system I'm trying to solve. I can make these 6, I can make these 12. It does not matter because these already have opposite signs. I'm going to work on those. So I'm going to multiply this by 4, and I'll multiply this by 3. So I get 8x minus 12y is equal to 36. I get 9x plus 12y is equal to 24. Adding it together, I get 17x, this cancels, is equal to 60. Divide by 17, so x is 60 17ths. All right, so not the most fun answer to try to plug in somewhere, but again, we're going to take this and plug it in to the other problem. All right, so we're going to take this and plug it in. We'll go here. All right, so 3 times 60 17ths plus 4y is equal to 8. So then this would be 180 over 17 plus 4y is equal to 8. Subtract 180 over 17. So we now have 4y is equal to, if I make this like match, this would be 180 as a denominator, so 8 times 180 would be the numerator. So 1440. Subtract the 180, and this is 1260 over 17. Then we're going to divide by 4 or multiply by a fourth is the same thing. So then y would be equal to, if I do 1260 divided by 4, I get 315 over 17. And I feel like that is not correct. So let me think about what I did. 3 times 60 is 180. I'm going to have 8 minus 180 over 17. Which should have just been 44. So what did I do? Not figuring out my mistake, and it's making me angry. Oh, I made it over 180 instead of 17. Have mercy. So way up here. I don't know why I was thinking 180 needed to be my common denominator. How dumb am I? All right. So I want this to be over 17. So 8 times 17. So 136 minus 180 does give me negative 44. So when I multiply that by a fourth, I get negative 11 17ths, which is the answer that was in my head. All right. Sorry, that was dumb on my part. Here is our answer. All right. So these last two videos that I've made have had like a really dumb mistake in them. I apologize for that, but at least you know I'm human. We all make them. That's why I'm pretty lenient when you make them. All right. So something else that's going to appear again, usually not on your test, but in Math Excel, is being able to name the system. So if your system has at least one solution, it's consistent. If it only has one, then it's independent. If it has infinite solutions, then it's dependent, which should make some sense. Like independent means it has a solution in one instance. Dependent means it has a solution all of the time. One equation is dependent on the other. And then it's considered to be inconsistent when there's no solution. So all of the ones that we've done so far, except for that one that we graphed where they were the same line, have had one solution. Those are all consistent and independent. The one that we graphed where it was the same line, I said it was infinite solutions. That one's consistent and dependent. For it to be inconsistent, it has to have no solution. So remember that we can get infinite solutions and no solutions when we are graphing or when we're solving algebraically. Graphing, infinite solutions is when they're the same line. No solution is when they're parallel to each other. So they don't intersect. All right. If you are doing it algebraically, if your variables cancel out and you're left with something like 2 is equal to 2 or 0 is equal to 0, then that's infinite solutions. If your variables cancel out and you're left with something like 2 is equal to 0, well, that's not true. So then it's no solution. All right, so last example, we're going to do some elimination here, and I believe we can just multiply by 2. And my goal is to make those y's both of 4, make it a -4 here and a +4 here. But what I actually accomplish is making the x's also opposites. So what that does is when I add, the x's disappear, the y's disappear. So I've got 0. And over here on the other side, 8 plus 7 gives me 15. Well, 0 does not equal 15, so this is no solution. Right, so again, that previous slide, make sure that you have written all of that down so that in Math Excel, when they ask you after you solve if it's a consistent or an inconsistent or a dependent or an independent, you can answer their questions. If you have more questions about how to solve these things, let me know. But those are the only examples that I have for you. Again, sorry for messing that one up. I don't know what I was thinking.